Pause the video, read the question, draw a correct free body diagram, and write your sum of fx, sum of fy equations, and check your answers. Since the car is parked on a slope, it is similar to a ramp or an inclined plane. So the car will have a weight vector perpendicular to the earth. It will have a normal because it is on a surface perpendicular to the surface. In an inclined plane, the x is parallel to the incline. Y is vertical or perpendicular to the x. By looking at this diagram, we notice that weight is at an angle. So using the normal vector, we're going to extend that back to make a right triangle so we could resolve the weight into wx and wy. Due to similar triangles, the theta of the inclined plane or the slope is the same theta that is in the right triangle of the weight. Since wy is next to the theta, it is resolved to w cosine theta. Wx is opposite the theta, so it's w sine theta. Now we're going to write our sum of fx and sum of fy. When I write the sum of fy, we only look at the y vectors. The y vector is vertical. Since it's vertical, it is only the normal and wy. Going up, we're going to make positive, so that is n minus wy, because wy is going in the opposite direction. This is equal to ma. Since it's not accelerating in the y direction, ma is equal to 0. So n is equal to wy. Next, in the x direction, x is parallel to the inclined plane or the slope. If you notice, the only vector that is parallel to that slope is the wx. So fx is going to equal to wx, which is equal to ma. ma is not equal to 0 because we are looking for acceleration. So we're going to substitute in for part A. To find the acceleration, we already know wx. wx is w sine theta from here. This is equal to ma. W, remember, is equal to mass times gravity. So this is mg sine theta equals to ma. The masses cancel out. So acceleration is g sine theta, or 9.8 meters per second squared sine 36 degrees. If you punch that into the calculator, you will get approximately 5.81 meters per second squared. So for part B, we are going to determine how fast it was moving. We know that the car is starting at rest because it was parked. So that means our v initial is 0 meters per second. The distance that we are moving is 30 meters. We just calculated acceleration as 5.8 meters per second squared, and we're looking for final velocity. So the only kinematics equation with these four variables is vf squared, v naught squared, plus 2ax. v naught squared is 0, so we could cancel it out. To solve for vf, we know vf, I need to take the square root on the left side, which means I have to take the square root on the right side. So this is 2ax. So square root of 2 times acceleration, which is 5.8 meters per second squared, times 30 meters. And then you're going to take the square root of that, and you should get approximately 19 meters per second. Pause the video, draw the correct free body diagram, write your sum of fx, sum of fy, and check your answer. So if I draw the free body diagram for this particular picture, you should have 4 vectors. It's going to have weight perpendicular to the earth. It's going to have normal straight up perpendicular to the ground. It has an applied force or a pull force at an angle, FP, at an angle of 45 degrees. And it also has friction because the force of friction is given to you. Since the object is being pulled to the left, it's going to be going towards the left. Friction must oppose the motion, so it's going to go to the right. So if you notice, we are on a flat surface. Since this is a flat surface, y is perpendicular to the earth, x is parallel to the earth. So we notice FP is at an angle. So we must resolve that into x and y using sine and cosine. FP is at an angle and it must be resolved into x and y. So I'm going to make a right triangle. Since the FP vector goes northwest, my x vector must go towards the west. My y vector must go towards the north. This is a right triangle. My angle was provided as 45 degrees. So FPX is next to the angle. So this is going to be FP cosine theta. FPY is opposite the angle. So this is FP sine theta. So now I could write my sum of Fy and sum of Fx equation. So if I have to write a sum of Fy equation, there are 2 vectors that are going up. I have normal that is going up. I also have Fpy going up because this vector went northwest. It is opposed by weight equal to ma. Since it's not going in the vertical direction, this is equal to 0. Writing the sum of fx, we look at the fx vector. So we know that fp was resolved into y and x. We said the x went towards the west or the left, and FPY went upward or north. So if I look at my x and y, my x is parallel to the ground. So the 2 vectors that are in the x direction is my FPX and my friction. The direction you are moving, you want to make positive. So FPX will come first, minus friction, because friction is going in the opposite direction. This is equal to MA. MA is not equal to 0 because we are looking for acceleration. The reason we make the direction we move in positive is that it counts for sine in m times a. So now we could plug in FP cosine theta is FPX from down here minus friction. Friction was given to you. This is equal to MA. So FP is 400 newtons. Cosine angle is 45 degrees minus 75 newtons that was given. This is equal to the mass, which is 70 kilograms, times acceleration. So I need to divide both sides by 70 kilograms. Since the acceleration came out positive, this tells us that the object is moving in the direction that is given. So since the pull is to the left, acceleration came out positive, it is moving to the left. If I solve this acceleration and it came out negative, it's actually slowing down. Pause the video, draw the free body diagram, write your sum of fx, sum of fy equation, and check your answers. The diagram should have consisted of 3 vectors. You should have weight perpendicular to the earth. You should have normal perpendicular to the surface. And you should have had the applied force parallel to your inclined plane. There is no friction because I told you it was frictionless. So the vector that is at an angle is weight, because on an inclined plane, the x gets rotated. The x is parallel to the inclined plane. The y is perpendicular to that inclined plane. Using the normal as a guide, we're going to make a right triangle to resolve the weight into x and y. The x component is going to go down the ramp. The y component is going to go opposite of the normal. The angle of the inclined plane is given as 30 degrees. This angle is the same as the angle for the weight due to similar triangles. So we know that Wx is opposite the theta. So this is going to be W sine theta. Wy is next to, so that's going to be W cosine theta. Now I'm going to write a sum of fx and sum of fy. You really don't need the y equation here, but we're going to write it just for practice. Remember, the y is perpendicular to the surface, so the vectors that consist of the y is fy is going to be normal because it's going up, minus wy. This is equal to ma. This is equal to 0. And again, we don't need the fy equation, but we are just doing it for practice. In the x direction, x, we noted, is parallel to the inclined plane. We have 2 vectors along the x direction. We have fa, because that's parallel to the inclined plane. And we also have wx that is along the inclined plane, parallel to it. So any vector parallel to the inclined plane is in the x direction. So, as before, the direction that you are moving, you want to make positive because it accounts for the sign in MA. FA is being pulled up, so that's going to be positive, minus opposed by WX. This is equal to MA. So FA minus WX, which is W sine theta. This is equal to MA. We know that W is equal to mg, so I'm going to substitute in. So that's mg sine theta, which is equal to ma. So I'm going to divide both sides by mass because we want to solve for acceleration. And now I'm going to substitute in. Fa was given as 150 newtons minus 15 kilograms. The mass is given in your picture. Gravity is 9.8 meters per second squared, sine 30 divided by 15 kilograms, which is 5.1 meters per second squared. So this object is being put up the ramp with an acceleration of 5.1 meters per second squared. Pause the video, read the question, draw your free body diagram, write a sum of fx and sum of fy equation, and check your answer. Since there are two objects, we have to draw two free body diagrams. So for object A, we're going to have weight going down perpendicular to the earth, and we have tension pulling it up. For object B, we are going to have weight, WB, pulling it down, tension pulling it up. The tensions are the same because A and B are connected by a single rope. And in Physics 1, the rope, if it's the same rope, the tension along it is the same, and it is massless. We also know that A has 5 kilograms mass, B has a mass of 2 kilograms. By just thinking logically, we know that A is going to go down and B is going to go up. Now I'm going to write a summation y equation. So for summation fy for the A, the direction we are moving, we are going to make positive. Since it is going down, WA is positive, minus T, because T is going in the opposite direction. This is equal to MA. We need to write the subscript because this is the mass of A only times the acceleration. If you write it in the opposite direction, you must account for direction for the acceleration, and you must put a negative sign in. This is why we always make the direction we are moving positive, because you do not want to forget this correction. Now I'm going to write a Fy equation for B. Since it's moving upward, I know T is positive, minus WB equals to MB times A. Since the ropes are the same, the tension is the same. Since you are tied by one rope, the acceleration of the system will be the same. So now we have two equations, two unknowns. So we're going to solve for the T from the top one and plug it into the bottom one and solve for the acceleration. So to solve for T on the top, we need to add a T to both sides and subtract a MA on both sides. So if I do that, T becomes WA minus MAA. So now I'm going to plug this into the bottom equation. So WA minus MAA minus WB equals MBA. I'm going to put all the A's to the same side, so I need to add a MAA to both sides. So now if I simplify this, this becomes MBA plus MAA is equal to WA minus WB. We could factor out an A, so this is MB plus MA. This is equal to MAG, because weight of A has to equal to mass of A times gravity. Same goes for WB. That's mass of B times gravity. So now I'm going to divide both sides of MB plus MA. MB plus MA. And you could even factor out a G on top. And if I do that, that's G MA minus MB over MB plus MA. To account for space, I'm going to erase some of this and rewrite it. So I'm just rewriting it. And now I'm going to plug in. Gravity is 9.8 meters per second squared. MA was 5 kilograms minus 2 kilograms of B divided by 5 kilograms plus 2 kilograms. And if you plug this into the calculator, you should get goes to 4.2 meters per second squared. So for part B, we need to use the information in part A. Since the object is falling, we know it started at rest. It is not in free fall. We know the acceleration is going to be 4.2 meters per second squared. And we know that x or y is going to be 2 meters. So we're looking for time. So the only kinematic equation with these variables is y is equal to v naught t plus 1/2 acceleration t squared. V naught t is equal to 0, so y is equal to 1/2 at squared. We're solving for t, so I need to multiply both sides by 2. The 2's cancel out with a half. I need to divide both sides by an a. The a's cancel out, so we get t squared is equal to 2y over a. And then I need to take the square root. So if I plug this in, it's 2 times 2 meters divided by 4.2 meters per second squared. Take the square root. 0.976 seconds. Pause the video, draw a free body diagram, write a sum of fx and fy equation, and check your answers. Again, like the previous problem, this one you need to draw 2 free body diagrams. Why? There are 2 objects. So A will have weight and again, you want to label it weight A and weight B because they're not the same weight. It's going to have a normal because it's on a table. And it's going to have a tension to the right because the rope is pulling it towards the right. And that's it. It's a frictionless table. For B, we're going to have weight due to the B, due to gravity. And then we are going to have tension. If we write our summation equation, we're going to practice the Fy. We don't need it for this problem, but we're just going to write it. Normal is going up, so it's going to be positive. Normal minus WA. This is equal to MA. And the mass here is A. You need to make sure you label this. This is equal to 0 because it's not moving in the vertical direction. My Fxa is going to be T. That is the only vector. Remember, it's on a table. So this is my X and this is my Y. So T is parallel to the X. So it's T is equal to M A. So mass of A times acceleration. So for B, it's going to be sum of Fyb. This B mass is going to pull A down. So the direction that B is moving is down. So my weight is going to be positive because it is moving in the same direction, minus T because T is in the opposite direction, times MBA. And when we make weight positive, it accounts for the direction in the acceleration. Now this is two equations to unknown. Since it's one rope, the tension is the same, and since they're tied by one rope, the acceleration is the same. Now I'm going to substitute in for T. So we said that T is MAA, so this is going to be WB minus MAA equals to MBA. I'm going to add a MAA to both sides. And then divide. So then WB becomes MBA plus MAA. You could factor out acceleration. This is equal to WB. Divide both sides by MB plus MA. So A becomes WB over MB plus MA, which is mass of B, because it's the weight of B, times gravity, MB plus MA. A is 20 kilograms and B is 10, so the top is going to be 10 kilograms times 9.8 meters per second squared divided by 10 kilograms plus 20 kilograms. So if you solve it, you get 3.27 meters per second squared. To solve for the tension, you could plug it into any of the T equations. The easiest one to plug in is this one right here. So T is equal to MA. A was 20 kilograms times 3.27 meters per second squared, which is equal to 65.3 newtons. And the tension here, if you plug it in, you will also get 65 newtons. So for vectors at an angle, draw a correct free body diagram. If that vector is at an angle, resolve it into x and y. So if you are on a flat surface, the x is horizontal, the y is vertical. If it does not fall in the x, horizontal, and the vertical plane, it is at an angle, and you need to make it into x and y. If you are on an inclined plane, ramp, or slope, the x is along the inclined plane, the y is perpendicular to the inclined plane. So if the vector does not lie on the x or the y coordinate system, it is at an angle, and you must resolve it into x and y using cosine and sine. After that, you write a sum of fx and a sum of fy equation. Note again, F net is ma, weight is equal to mass times gravity, and friction is equal to mu n.